Good morning, students. See, in the last class, we were discussing about, in the last class, we were discussing about Fender's Raoult's law reduces to Henry's law, and we have also seen Raoult's law for the solution containing non-volatile solute in a volatile solvent, and what happens to the vapor pressure of solution containing non-volatile solute. Is it right? See, today, now let us come to discussion of ideal solution and non-ideal solution. Here in the board, on the board you might have seen, you may be observing that I have written ideal solution on one part, that is left hand side part, and non-ideal solution on the right hand side part. See, I will tell you for what reason I have written like this one. Is it clear? First, let me come to know what is ideal solution. What is ideal solution? See, a binary liquid solution, binary liquid solution which obeys Raoult's law at all concentrations and temperatures is called as an ideal solution. See, what is ideal solution, or define an ideal solution? A binary liquid solution. Ideal solution is a binary liquid solution which obeys Raoult's law at all concentrations and temperatures is called as ideal solution. Is it right? See, now what are the characteristics of this ideal solution? Characteristics of ideal solution. Characteristics of ideal solution. See, characteristics of ideal solution. First one. See, it obeys Raoult's law at all concentrations and temperatures. Ideal solution obeys Raoult's law at all concentrations and temperatures. That is mathematically we are going to express as Pa is equal to Ka into Pa naught for liquid A, Pb equal to Chi B into Pb naught for liquid B, and P total total vapor pressure of the solution is equal to Pa plus Pb, partial vapor pressure of liquid A and partial vapor pressure of liquid B. Is it right? This is the first characteristic. What is the first characteristic of this ideal solution? Ideal solution obeys Raoult's law at all concentrations and temperatures. It means at all concentration and temperature condition, this partial vapor pressure of liquid A becomes equal to product of its mole fraction in the solution and its vapor pressure in pure state at that temperature. Similarly, for component B, liquid B, and total vapor pressure over the solution is the sum of partial vapor pressure of component A and partial vapor pressure of component B. Now, second one is delta mix P is equal to 0. What is the meaning of this one? Delta means change. Mix means mixture. P means volume. See, here there is no change in value after mixing the two liquids. There is no change in value after mixing the two liquids. What do you mean by this one? Take for example, suppose if you have taken 100 ml of liquid A, 100 ml of liquid A plus 100 ml of liquid B, 100 ml of liquid B. So what is the resulting value? 100 plus 100. We used to get 200 ml of solution. 200 ml of solution. Then we say that there is no change in value after mixing the two liquids. 100 plus 100 is 200 ಆತಂತಂದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೇ ಬದಲಾವಣೆ ಆಗಿಲ್ಲ ಅಂತ ಹೇಳ್ತೀವಿ. ಸರ್ ಮತ್ತೆ 100 plus 100 is 200 ಆತಲ್ರಿ ಅಂತ. ಹೌದು 200 ಆಗೈತಿ. ಅದಕ್ಕಿಂತ ಹೆಚ್ಚಾಗುವುದಾಗಲಿ ಅಥವಾ ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಆಗುವುದಾಗಲಿ ಆಗಿಲ್ಲ. ಹಂಗೇಂಗ್ರಿ ಸರ್ 100 ml ಲಿಕ್ವಿಡ್ A ಮತ್ತು 100 ml ಲಿಕ್ವಿಡ್ B ತಗೊಂಡಾಗ 200 ಆಗತೈತಲ್ರಿ. ಹೆಚ್ಚಾಕತಿ ಕಡಿಮೆ ಆಕತಿ. ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ ಒಳಗ ಆ ರೀತಿ ಆಗ್ತೈತಿ. ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ ಇತ್ತಂದ್ರೆ 100 plus 100 200 ಬಂತಂದ್ರೆ we say that delta makes P is equal to 0. No change in value after mixing the two components. Is it right? See, in the non-ideal solution, 100 plus 100 ml of liquid A and 100 ml of liquid B. Now mix ಮಾಡಿದಾಗ it may come to 190 ml. 100 plus 100 190 ಹೆಂಗ ಆಕೈತ್ರಿ? ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ ದಾಗ ಆಕೈತಿ. 100 plus 100 even you may have 205 205 ml. 100 plus 100 205 ml ಆಗ್ತಕ್ಕಂತ. There is expansion in volume or there is a decrease in the volume of the solution. That is in case of what? In case of non-ideal solution. But in case of ideal solution, we write delta mix B is equal to 0. That is no change in value after mixing the two components. 100 plus 100, you get 200. Is it right? Then coming to delta mix H is also equal to 0. Delta mix H here it means enthalpy, heat energy, enthalpy, heat energy. Is it right? See, suppose if you have taken liquid A at 25 degrees Celsius and liquid B is also at the same temperature, 25 degrees Celsius. When you mix these two, and what you are going to get? You are going to get solution, primary liquid solution. If the temperature of this solution also remains the same, there is neither increase in the temperature nor decrease in the temperature. ಆ ರೀತಿ ಯಾಕಂದ್ರೆ ಲಿಕ್ವಿಡ್ ಎ 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಒಳಗೈತಿ, ಲಿಕ್ವಿಡ್ ಬಿ 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಒಳಗೈತಿ. ಎರಡು ಲಿಕ್ವಿಡ್ ಟೆಂಪರೇಚರ್ ಸೇಮ್ ಐತಿ. ಸೇಮ್ ಇದ್ದ ಅದನ್ನ ನಾವು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಸೊಲ್ಯೂಷನ್ ಟೆಂಪರೇಚರ್ ಅಷ್ಟೇ ಬರ್ತಂತಂದ್ರೆ ಅವಾಗ ಏನ್ ಹೇಳ್ತೀವಪ್ಪ ಅಂತಂದ್ರೆ ಡ್ಯೂರಿಂಗ್ the mixing of these two liquids, liquid A and liquid B, there is no change in heat. Neither heat is absorbed nor heat is evolved. Heat absorbed ಆಗಿಲ್ಲ, heat liberate ಆಗಿಲ್ಲ. So ಆ ಒಂದು ಕಾರಣಕ್ಕಾಗಿ ಸೊಲ್ಯೂಷನ್ ಟೆಂಪರೇಚರ್ ಏನು ಉಳಿದಿದೆ? ಇವೆರಡು ಇನಿಷಿಯಲ್ ಟೆಂಪರೇಚರ್ ಇರ್ತದೆ, ಸೇಮ್ ಉಳಿದಿದೆ. Is it right? So we say that delta mix H equal to 0. ಇದು ಯಾಕೆ ಹಿಂಗಾಕೈತಿ ಅನ್ನೋದಕ್ಕೆ fourth characteristic. See here. Now let us come to fourth characteristic. The interactions between the components, molecules of the components, pure components. See here, this is liquid A. Right? Idrolaga molecules of A astadavu, and there is an interaction between neighboring molecules. Liquid A will have interaction with another molecule A. Right? And here liquid B. So interaction between the molecules. BB interaction ಅಂತಾರೆ. ಇದು AA interaction, ಇದು BB interaction. ಇವೆರಡನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದ್ರಪ್ಪ ಅಂತಂದ್ರೆ when you get a solution, now we will have new interactions. That is, molecule A will have interaction with molecule B. Molecule A of component A will have interaction with molecule B of component B. So it is in a pure state. Interactions between the molecules in pure state. AA interaction, BB interaction. Whereas this is interaction between the molecules in solution. So molecule of component A will have interaction with molecule of component B, and that is what we call it as AB interaction. And when these AB interactions are similar to those of AA interactions and BB interactions in the pure state, then we are going to have there is no change in volume after mixing the two components, and there is no change in enthalpy after mixing the two components. So that is what fourth characteristic. So how to write this one? The AB interactions in the AB interactions in the solution are similar to those of AA and BB. 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 AA and BB interactions in pure state. In pure state. Then we say that when the AB interactions are in the solution are similar to those of AA interactions and BP interactions in the pure state, then what will happen? There is no change in value after mixing the two components, and there is no change in enthalpy after mixing the two compounds. Is it clear? Now, examples for this one. Examples for this one. One thing I will make it clear that there is no perfectly ideal solution. There is no perfectly ideal solution. But the liquid mixtures, binary liquid mixtures, which I am going to write, they show nearly ideal behavior. Nearly ideal behavior. They are not perfectly ideal, but they show nearly ideal behavior. So what are the examples? First one is that is N-hexane plus N-heptane, normal hexane and normal heptane. Second example is ethyl chloride and ethyl bromide. Ethyl chloride and ethyl bromide. Ethyl bromide. You take another example you may take here. Another example you may take chlorobenzene and bromobenzene. Chlorobenzene and bromobenzene. Another example you may take, that is carbon tetrachloride and silicon tetrachloride, SiCl4 tetrachloride, CCl4 and SiCl4. Is it right? One more example you may have benzene and toluene. Fifth example, benzene and toluene. Is it right? See, these are what? These are few binary liquid mixtures which show nearly ideal behavior. They are not perfectly ideal. There is no example for perfectly ideal solution. Is it clear? Now, let me come to the discussion of non-ideal solution. See. Now let me come to the discussion of non-ideal solution. See here. First one, let us see what is non-ideal solution. What is non-ideal solution? See, already we know that ideal solution is one which obeys Raoult's law at all concentrations and temperatures. Then, what is the definition of non-ideal solution? Which does not obey a solution which does not obey Raoult's law at all concentrations and temperatures is called as non-ideal solution. See, a solution which does not obey Raoult's law or capital Raoult's law at all concentrations and temperatures is called as non-ideal solution. Is it clear? See, what is non-ideal solution? A solution which does not obey Raoult's law at all concentrations and temperatures. Now, characteristics of non-ideal solution. Characteristics of non-ideal solution. See, first characteristic, both the components and solution do not obey Raoult's law. Both the components and solution do not obey Raoult's law. See, it means that is, we may write PA is not equal to Ka into PA naught. Raoult's law obey PA becomes equal to Ka into PA naught. Raoult's law obey PA is not equal to Ka into PA naught for component A. Then PB is also not equal to Chi B into PB naught, and P total solution P total is not equal to PA plus PB. PA plus PB. This is what? This is the first characteristic of non-ideal solution. Both the components and solution do not obey Raoult's law at all concentrations and temperatures. Now, here second characteristic, delta mix phi is not equal to 0. Means, as I have explained, in case of ideal solutions, suppose if you take 100 ml of liquid A and 100 ml of liquid B, if it is ideal solution, we get 200 ml of the solution. So the total value of the solution is 200 ml. But in case of non-ideal solution, when you take 100 ml of liquid A and 100 ml of liquid B, the volume of the solution is not 200 ml. Either it is less than 200 ml or more than 200 ml. Is it clear? So therefore we write delta mix C is not equal to 0. Then third one, delta mix H is also not equal to 0. It means there is a change in enthalpy. Suppose if you have taken liquid A at 25 degrees Celsius, similarly liquid B is also at 25 degrees Celsius, then the temperature of the solution, if it is 25 degrees Celsius, then it will be ideal solution. But now, what will happen? Either there is increase in the temperature of solution or decrease in the temperature of solution. Increase in the temperature of solution means endothermic process, heat will be absorbed. Decrease in the temperature of the solution means heat will be evolved. Is it right? So therefore, what will happen? Delta mix H is equal to 0. Is not equal to 0. Now, fourth characteristic. Here what we have written? The AB interactions in the solution are similar in case of ideal solution, but in case of non-ideal solution, the AB interactions are different from AA interactions and BB interactions. The AB interactions in the solution are different from those of AA and BB interactions in their pure state. Interactions in their pure state. Then what will happen when the interactions are different when compared to interactions in pure state? So what will happen? Either there will be increase in volume or decrease in volume, and similarly either there is increase in the temperature of the solution or decrease in the temperature of solution. Is it clear? Now, here I have told in the beginning why I have written like this one. See, for example, if you are supposed to write, if you are asked to write the characteristics of ideal solution, only this much you are going to write. So, question will be asked for 3 marks. So, therefore, out of these 4 characteristics, you are supposed to write any three. Even if you write only this much, you will get the marks. Okay. See, first characteristic carries 1 mark. Second characteristic, delta mix V is equal to 0, carries 1 mark. Delta mix H is equal to 0, that carries 1 mark. Characteristics ಅಷ್ಟ ಬರೀರಿ ಅಂತಂದ್ರೆ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಅಷ್ಟ ಬರೀರಿ ಅಂತಂದ್ರೆ ಇದರ ಬೇಕು 3 ಮಾರ್ಕ್ಸ್ ಇದು 3 ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್. Similarly, what are the characteristics of non-ideal solution ಅಂತಂದ್ರೆ you are going to write only 3 out of these 4 for non-ideal solution. And sometimes what will happen, they will ask write any 3 differences between ideal and non-ideal solution. Ideal ಮತ್ತು non-ideal solution the difference ಬರೀರಿ ಅಂತಂದಾಗ then what you are supposed to do, you have to write a tabular column and you have to make the difference between ideal solution and non-ideal solution. ಎರಡೂ ಬರಲಿ ಅಂದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ ಡಿಫರೆನ್ಸ್ ಆಗುತ್ತೆ. ಒಂದೊಂದು ಬರಲಿ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್, ಇದನ್ನ ಇಷ್ಟ ಬರಲಿ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್, ಇದನ್ನ ಇಷ್ಟ ಬರಲಿ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಆಫ್ ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್. ಎರಡೂ ಟ್ಯಾಬ್ಲೆಟ್ ಕಾಲಮ್ ಅಕ್ಕಪಕ್ಕ ಸೈಡ್ ಬೈ ಸೈಡ್ ಬರಬೇಕು ಅಂತಂದ್ರೆ then that will become a difference. Is it clear? So how to write in the examination based on the type of question asked. Now, let me come to types of non-ideal solution. Here you might have observed. Here I have not given any example. Because in the types of non-ideal solutions, we are going to see the examples separately. Is it right? So first let me clean the board, then continue with the types of non-ideal solutions. Types of non-ideal solutions. See, there are two types of non-ideal solutions. One is non-ideal solution showing positive deviation from the Raoult's law, and second one is non-ideal solution showing negative deviation from the Raoult's law. See, there are two types of non-ideal solutions. There are two types of non-ideal solutions. One non-ideal solution showing positive deviation, and another one is non-ideal solution showing negative deviation from the Raoult's law. So that also I am going to write as we have written ideal and non-ideal solutions. So it will be easy for us to compare non-ideal solution showing positive deviation and non-ideal solution showing negative deviation. Is it right? See, types of non-ideal solutions. Types of non-ideal solutions. First, let me complete the cleaning of this board. Is it right? See. There are two types of non-ideal solutions. One is non-ideal solution showing positive deviation from the Raoult's law. Another one is non-ideal solution showing negative deviation from the Raoult's law. See. What are the characteristics and what are the examples for each type of non-ideal solution? See, here types of non-ideal solutions. Types of non-ideal solutions. First one. Non-ideal solution. Non-ideal solution showing positive deviation. Deviation from Raoult's law. Raoult's law. Then here let me write the second type, that is non-ideal solution. Non-ideal solution showing negative deviation from Raoult's law. Is it right? See, characteristics. First one. Positive deviation means, see, there is increase. Positive ಅಂದ್ರೆ there is increase. Negative ಅಂತಂದ್ರೆ decrease. Is it right? See, PA partial vapor pressure is greater than what we expect it from Raoult's law. PA is greater than Ka into PA naught. Similarly, PB partial vapor pressure of component B is greater than what? Chi B into PB naught. And when these two are more, so what will happen? P total is greater than PA plus PB. Or you may write here, actually we have to write it in this way. See, this one is Chi A into PA naught plus Chi B into PB naught. Then non-ideal solution shows positive deviation. What is the reason for this one? To look at that second thing, if you take, see here, right? This is AA interaction in pure component liquid A. This is BB interaction in pure component liquid B. When you mix these two, what will happen? These interactions are broken. And new interactions come to exist. ಇಲ್ಲಿ ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಕಾಂಪೋನೆಂಟ್ A ಅಥವಾ ಲಿಕ್ವಿಡ್ A ಒಳಗೆ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ A are nearer, so it like similarly liquid B ಒಳಗೂ molecules of B are nearer, so it like when you mix these two ಏನಾಗಬೇಕು ಅಂತಂದ್ರೆ there is weaker interactions weak ಇರೋದ್ರಿಂದ ದೂರ ಹೋಗ್ತಾವ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ದೂರ ಹೋಗ್ಬೇಕು ರೇಟ್ ಆಫ್ ವೆಪರೈಸೇಷನ್ ಹೆಚ್ಚಾಗ್ತಂದ್ರೆ ಪಾರ್ಷಿಯಲ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಏನಕ್ಕೆ ಹೆಚ್ಚಾಗ್ತದೆ ಇದಕ್ಕೆ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡಿ ಇದು ರೌಲ್ಟ್ಸ್ ಎರಡು ಈಕ್ವಲ್ ಆದ್ರೆ ರೌಲ್ಟ್ಸ್ ಇದು ಹೆಚ್ಚಾಗೈತೆ ಅಂತ ಏನಾಗೈತೆ ಬಿಕಾಸ್ ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆರ್ ಅಪಾರ್ಟ್ little bit more farther. So rate of evaporation is more. When rate of evaporation is more, what will happen? That increase partial vapor pressure of component A as well as partial vapor pressure of component B. So therefore, total vapor pressure of the solution is greater than that what we expected from Raoult's law. Is it right? So ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ಸಮೀಪವಾಗಿರೋದ್ರಿಂದ ಹೌದಾ ವ್ಯಾಲ್ಯೂಮ್ ಕಡೆ ಇದು 100 ml ಇತ್ತು ಇದು 100 ml ಈಗ ಏನಾದ್ರೆ ಎರಡು ದೂರ ಹೋದಾಗ ವ್ಯಾಲ್ಯೂಮ್ ಏನಾಗ್ತೈತಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತೈತಿ ಸೊ ದೇರ್ಫೋರ್ ದಟ್ ಈಸ್ ಪಾಸಿಟಿವ್ ಡಿವಿಯೇಷನ್ ಒಂದು ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೇನೆ ನಿಮಗೆ ಕ್ಲಾಸ್ ರೂಮ್ ನಾಗ ಇತ್ತಂದ್ರೆ ಹೇಳಕ್ ಬಹಳ ಚಂದ ಆಕೈತಿ ಒಂದ್ ಕಡೆ ಎಲ್ಲಾ ಹುಡುಗರು ಇರ್ತಿದ್ರು ಇನ್ನೊಂದು ಕಡೆ ಎಲ್ಲಾ ಹುಡುಗಿಯರು ಇರ್ತಿದ್ರು ಆಯ್ತಾ ಸಪೋಸ್ ನಾನ ಇಬ್ರು ಕೂಡ್ಕೊಂಡ್ರಿ ಅಂತಂದ್ರ ಒಂದ ಡೆಸ್ಕ್ನಾಗ ಒಂದ್ ಹುಡುಗ ಒಂದ್ ಹುಡುಗಿ ಕೂಡ್ರಿ ಅಂತಂದ್ರ ಏನ್ ಮಾಡ್ತಿದ್ರಿ ನೀವು ಅವ ಏನಾದ್ರು ಸರ್ ಹಿಂದೆ ಕೇಳ್ತಾರ ಅಂತ ಹೇಳಿ ಹುಡುಗಿಯರು ದೂರ ಸರಿತಿದ್ರಿ ಸೊ ಇಂಟ್ರಾಕ್ಷನ್ ವೀಕ್ ಆಗಿತ್ತು ದೂರ ಹೋಗ್ತಿದ್ರಿ ವ್ಯಾಲ್ಯೂಮ್ ಹೆಚ್ಚಾಗ್ತೈತಿ ವ್ಯಾಲ್ಯೂಮ್ ಏನಾಗೈತಿ ಹೆಚ್ಚಾಗ್ತೈತಿ ಆಯ್ತಾ ಸೊ ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್ ಡೆಲ್ಟಾ ಮಿಕ್ಸ್ ಬಿ ಈಸ್ ಗ್ರೇಟರ್ ದನ್ expected 100 plus 100 ಬರಬೇಕು 200 ಬರಬೇಕಾದದ್ದು ಏನಾಗೈತಿ 205 210 whatever it may be but it is more than 200 ml so therefore second characteristic is delta mix V is greater than 0 delta mix V is greater than 0 or positive we write what we expect or positive. Is it right? Then similarly third characteristic. See, ಈಗಾಗಲೇ ಇರತಕ್ಕಂತ ಇಂಟರಾಕ್ಷನ್ಸ್ ಅನ್ನ ಬ್ರೇಕ್ ಮಾಡಬೇಕಾದ ಎನರ್ಜಿ ಬೇಕಾಗುತ್ತೆ ಇಲ್ಲಿ ಎ ಮಾಲಿಕ್ಯೂಲ್ ನೋಡಿ ಇಂಟರಾಕ್ಷನ್ಸ್ ಅದಾವ ಅವನ್ನ ಬ್ರೇಕ್ ಮಾಡಬೇಕು ಬಿ ಮತ್ತು ಬಿ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ನೋಡಿ ಇಂಟರಾಕ್ಷನ್ಸ್ ಅದಾವ ಅದನ್ನ ಬ್ರೇಕ್ ಮಾಡಬೇಕು ಆಗ ಎ ಮತ್ತು ಬಿ ನಡುವೆ ಹೊಸ ಇಂಟರಾಕ್ಷನ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಇರ್ತಕ್ಕಂತಹ ಇಂಟರಾಕ್ಷನ್ಸ್ ಅನ್ನ ಬ್ರೇಕ್ ಮಾಡಬೇಕಾದ್ರೆ ಎನರ್ಜಿ ಅಬ್ಸರ್ವ್ ಆಕೈತಿ. ಇನ್ನ ಹೊಸ ಇಂಟರಾಕ್ಷನ್ ತಯಾರಾಗಬೇಕಾಗ ಎನರ್ಜಿ depends upon type of interaction. Weak interaction, strong interaction. ಇಲ್ಲಿ ಸಮೀಕರಣದಿಂದ interactions are strong. ಇಲ್ಲಿ ಸಮೀಕರಣದಿಂದ interactions are strong. When the molecules are far away, interactions are weak. When the interactions are weak, amount of energy released is less. When the amount of energy released during the formation of new interaction is less, that is not enough to break the existing interactions. ಹೊಸ ಇಂಟರಾಕ್ಷನ್ ತಯಾರಾಗಬೇಕಾದ್ರೆ ಏನ್ ಎನರ್ಜಿ ಬಿಡುಗಡೆ ಆಗತೈತಿ, ಹೀಟ್ ಎನರ್ಜಿ ಬಿಡುಗಡೆ ಆಗತೈತಿ, ಅದು ಯಾವುದಕ್ಕೆ ಸಾಕಾಗ್ತಾ ಇಲ್ಲ ಅಂತಂದ್ರೆ ಈಗಾಗಲೇ ಇರತಕ್ಕಂತಹ ಈ ಇಂಟರಾಕ್ಷನ್ಸ್ ಬ್ರೇಕ್ ಮಾಡಕ್ಕೆ. ಅವಾಗ ಏನಾಗೈತಿ ಅಂದ್ರೆ ಎನರ್ಜಿ ವಿಲ್ ಬಿ ಅಬ್ಸಾರ್ಬ್ ಫ್ರಮ್ ದ ಸರೌಂಡಿಂಗ್ಸ್. So when there is absorption of heat energy, we write delta H is positive. Delta H is positive or greater than 0. So therefore delta mix H is greater than 0 or positive. Endo ಹೊರಗಡೆ ಇರುತ್ತೆ ಪಾಸಿಟಿವ್. ಡೆಲ್ಟಾ H is positive ಅಂದ್ರೆ ಎಂಡೋಥರ್ಮಿಕ, ಡೆಲ್ಟಾ H is ನೆಗೆಟಿವ್ ಅಂದ್ರೆ ಎಕ್ಸೋಥರ್ಮಿಕ್ ಆಗುತ್ತೆ. ಆಯ್ತಾ? So therefore ಇದು now fourth characteristic interactions in terms of interactions, the AB interactions in the solution are weaker than those of AA and BB interactions in their pure state. So that what already we have seen. AB interactions in the solution are weaker than those of A interactions and BB interactions in their pure state. Now let me come to what do you mean by Henry? Non-ideal solution showing negative deviation. See, characteristics. See, first one. Here PA is greater than positive. Negative deviation of that PA is less than. PA, partial vapor pressure of component A, is less than Ka into PA naught. Similarly, PB, partial vapor pressure of component B, is less than Ka B into PB naught. And P total is less than Ka into PA naught plus Ka B into PB naught into PB. See, when this happens, once again, let us look into interactions in the solution and interactions in the pure state. So, idu AA interactions, idu BB interactions, pure state. ಈಗ ಹೊಸ ಈಗಾಗಲೇ ಇಂಟ್ರಾಕ್ಷನ್ಸ್ ಬ್ರೇಕ್ ಮಾಡೋಣ. A interaction ಮತ್ತು BB interaction break out. Now we are going to have formation of new interaction. AB interaction in the solution. See, in constantly AA molecules in component A are away. BB molecules in the component B are away. But when you mix these two, liquid A and liquid B, molecules of A and molecules of B are closer. Strong interactions. Attraction between molecule A and attraction between molecule B are strong. So therefore, what will happen? ಈಗ ದುಡ್ಡಿದ್ದಾಗ ವ್ಯಾಲ್ಯೂ ಹೆಚ್ಚು ಸಮೀಪ ಬಂದಪ್ಪ ಈಗ ಎರಡು ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ಸಮೀಪ ಬಂದ್ರೆ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ. ಈಗ ಆಗಲೇ ಕ್ಲಾಸ್ ರೂಮ್ ಒಂದು ಹೌದಾ, ಸ್ಟೂಡೆಂಟ್ಸ್ ಒಂದ್ ಸೈಡ್ ಆಮೇಲೆ ಗರ್ಲ್ಸ್ ಬಾಯ್ಸ್ ಒಂದ್ ಕಡೆ ಗರ್ಲ್ಸ್ ಒಂದ್ ಕಡೆ ನೋಡಿದ್ದೀವಿ. ಈಗ ಮ್ಯಾರಿಡ್ ಕಪಲ್ ನೋಡಬಹುದು, ಒಂದ್ ಕಡೆ ಎಲ್ಲ ಹಸ್ಬೆಂಡ್ಸ್, ಇನ್ನೊಂದ್ ಕಡೆ ಎಲ್ಲ ವೈಫ್ಸ್, ಒಂದ್ ಕಡೆ ಗಂಡಂದಿರು, ಇನ್ನೊಂದ್ ಕಡೆ ಹೆಂಡತಿ ಅಂತ ಸಪರೇಟ್ ಕೂತಾಗ ಏನಕ್ಕೈತಿ, ಏನ್ ಇವ್ರ ಎಲ್ಲ ಸಪರೇಟ್ ಕುಂಡಿಸ್ತಾರ, ನಮ್ಮನ್ನ ಜೋಡಿಯಾಗಿ ಕುಂಡಿಸಿದ್ರೆ ಬಹಳ ಚಲೋ ಇತ್ತ ಅಂತ. ನಾನು ಈಗ ಹೇಳ್ತಿದ್ದೇನೆ, ನಿಮ್ ಪೇರಾಗಿ ಕುಂತು ಬಿಡ್ರಿ, ನೀವು ಗಂಡ ಹೆಂಡತಿ ಕುಡಿಬಿಟ್ಕೊಂಡ್ರಿ, ಅವಾಗ ಹೆಂಗ್ ಕುಂಡಿರ್ತಾರೆ, ಒಬ್ರು ಕೈ ಹಾಕೊಂಡ್ ಕುಂಡಿರ್ತಾರ, ಸಮೀಪ ಬರ್ತಾರ. ಅವಾಗ ಏನಕ್ಕೈತಿ, ವ್ಯಾಲ್ಯೂಮ ಕಡಿಮೆ ಆಗ್ತದೆ. ಅವಾಗ ಏನಕ್ಕೈತಿ, ವ್ಯಾಲ್ಯೂಮ ಕಡಿಮೆ. ಇಂಟ್ರಾಕ್ಷನ್ ಸ್ಟ್ರಾಂಗ್ ಆಗ್ತದೆ, ವ್ಯಾಲ್ಯೂ ಏನಕ್ಕೈತಿ, ಕಡಿಮೆ ಆಕತಿ. ಸೊ ದೇರ್ಫೋರ್ ಡೆಲ್ಟಾ mix P is less than 0 or remained negative. Delta B mix is negative. Similarly, the third characteristic. See, ಈಗ ಇವು interactions weak ಇರೋದ್ರಿಂದ ಹೌದಾ, ಇವನು ಬ್ರೇಕ್ ಮಾಡಕ ಎನರ್ಜಿ ಕಡಿಮೆ ಆಗ್ತದೆ. Interactions weak ಇರೋದ್ರಿಂದ AA interaction ಮತ್ತೆ BB interactions weak ಇರೋದ್ರಿಂದ ಅವನ್ನ ಬ್ರೇಕ್ ಮಾಡಕ ಎನರ್ಜಿ ಕಡಿಮೆ ಆಗ್ತದೆ. ಆಮೇಲೆ ಇಲ್ಲಿ ಹೊಸ ಇಂಟರಾಕ್ಷನ್ ತಯಾರಾಗ್ತಾವ್ರಿ, A ಮತ್ತು B ಗಳು ಇವು ಸ್ಟ್ರಾಂಗ್ ಇಲ್ಲ. ಯಾವಾಗ ಸ್ಟ್ರಾಂಗ್ ಇಂಟರಾಕ್ಷನ್ ಇರ್ತದೆ, ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ರಿಲೀಸ್ಡ್ ಈಸ್ ಮೋರ್. So this is the energy released is more than enough required to break already existing interactions. So therefore some part of energy is excess and that will be given out. Some part of the energy is excess and that will be given out. So therefore we write delta mix H is less than 0 or negative. Delta mix H negative ಅಂತಂದ್ರೆ ಏನು, amount of energy is released, excess energy is given out. ಹೊಸ ಇಂಟರಾಕ್ಷನ್ಸ್ ತಯಾರಾಗಬೇಕಾಗ ಇವು ಇಂಟರಾಕ್ಷನ್ಸ್ ಸ್ಟ್ರಾಂಗ್ ಇರೋದ್ರಿಂದ ಹೆಚ್ಚಿಗೆ ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗ್ತದೆ. ಅಲ್ಲಿ ರಿಲೀಸ್ ಆಗಿರ್ತಕ್ಕಂಥ ಎನರ್ಜಿ ಇವು ಎರಡು ಇಂಟರಾಕ್ಷನ್ಸ್ ಅನ್ನು ಬ್ರೇಕ್ ಮಾಡಿ ಇನ್ನೂ ಉಳಿತೈತಿ ಹೊರಗೆ ಬರ್ತದೆ. ಡೆಲ್ಟಾ ಮಿಕ್ಸ್ H is less than 0 or negative, exothermic process. Now last point. See here, in terms of interactions, the AB interactions in the solution are stronger than those of AA and BB interactions in their pure state. See, is it clear? So interactions are strong over there. We are going to observe these two characteristics here also. So you may be asked, write the characteristics of non-ideal solution showing positive deviation from the Raoult's law, non-ideal solution showing negative deviation from the Raoult's law, or you may be asked to write differences between non-ideal solution showing positive deviation from Raoult's law and non-ideal solution showing negative deviation from Raoult's law. Next is examples for these. Examples. See. First one is A, C, D. See, what is this ACD? Acetone carbon disulfide. Acetone plus carbon disulfide. First one. Note it. Acetone and carbon disulfide. Acetone plus carbon disulfide. CS2 paper. CS2. A for acetone. Carbon disulfide. CD. Then second one is acetone plus benzene. AB. Acetone plus benzene. Next, AE. Acetone plus ethanol. Acetone plus ethanol. Next is CCl4 carbon tetrachloride plus CHCl3 chloroform. CC ಅಂದ್ರೆ carbon tetrachloride ಮತ್ತೆ chloroform. Then ಯಾವ್ದಪ್ಪ ಅಂತಂದ್ರೆ ethanol plus cyclohexane. ಆಮೇಲೆ ethanol plus water. Ethanol plus water. ಎಲ್ಲಿ ಬರಬೇಕು ಅಂತಂದ್ರೆ examples. First one is CB, chloroform plus benzene. C ಅಂದ್ರೆ chloroform, B ಅಂದ್ರೆ benzene. ಇಲ್ಲಿ ಯಾರು ಅಷ್ಟೇ ಹೇಳಿದ್ರು ಹೌದಾ? ಇಲ್ಲಿ A ಅಂದ್ರೆ acetone, B ಅಂದ್ರೆ benzene. Then second example you may take chloroform plus diethyl ether. ಹೌದಾ? Then acetone and chloroform. Acetone plus chloroform. ಆಮೇಲೆ water plus any acid. ಯಾವ ಬೇಕಾದ acid. Water you may add hydrochloric acid. Water you may add nitric acid. Water you may add sulfuric acid. Whatever it may be, water plus acid always forms in the non-ideal solution showing negative deviation from the Raoult's law. Acetone plus aniline. Acetone plus aniline. One more example. See. Is it clear? This is regarding what? Regarding examples of non-ideal solutions showing positive deviation from Raoult's law and negative deviation from Raoult's law. So, today let me complete the class. What we have studied? We have studied what is non-ideal solution or ideal solution. What are the characteristics of ideal solution? What is a non-ideal solution? What are the characteristics of non-ideal solution? Examples for ideal solution. Is it right? And we have also seen types of non-ideal solutions. That is non-ideal solution showing positive deviation from Raoult's law and non-ideal solution showing negative deviation from Raoult's law. Characteristics and examples for each type. Thank you.